Okay, I think it's recording. Let's hope it is. Okay, in my opinion, this problem was, the biggest issue was a discomfort with trig. So again, I remember Neumann said, the more you see something, the more you get used to it. It's just the issue with not getting used to it. So I tried to draw pictures out here. What you really need to know is that unit circle, or be very handy with your calculator so you can figure out how to get around. I changed this problem a little bit so that I can change the angles. But in this linear transformation, the t is first rotating points through minus 2 pi over 3 radians, which means that you're going clockwise. And it then reflects that point through the vertical x2 axis. And you're supposed to find the matrix representation of t. So the first step is to start with E1 in R2, which is 1, 0. And I've drawn it here. There's 1, 0. And I've drawn it on the unit circle so you can see it where it is placed. The first thing you're supposed to do is rotate that minus 2 pi over 3 radians. Well, 2 pi over 3 radians without the minus is right here. So you swing this clockwise exactly the same amount of degrees, or the same angle. So this yellow, or pea green on here, rotates me over here. So I just took that same angle and just went clockwise instead of counterclockwise. And that lands me exactly at this point right here, minus 1/2 and minus square root of 3 over 2. The second step is to reflect this through the vertical x2 axis. So there's a reflection. I just fold the piece of paper over, first scribble really hard with a pencil, and then fold over the y equals x line and see where, scratch it on the other side. This is the vector that you're going to get. So that's where I land, 1/2 comma minus square root of 3 over 2. So easy when you already have the unit circle drawn on there. So that gives me my t of E1. E2 is done the same way. I don't go through it as much. Here's where I start. Again, I have to rotate. Did I rotate the wrong direction? So I have to redo this problem. So I'd rotate this direction here, would land me here. And then I fold the piece of paper over, it's going to land me here. So the second step is actually going to lead me to this point here, not the first. So I'm going to correct that as a comment underneath because it's kind of hard to go through and re-record everything, and I'll correct it on the slides. Once you have the E2 and E1, you just put it into a matrix. T of E1 goes here, T of E2 goes here. That's your standard basis vector. So I don't think, looking from the other problems you did, that you had any issue with this other than it had trig in it. And then I had a few questions right at the end about these weird spaces, where vector spaces, where you had an inner product and it was not an inner product you were used to. So all I'm going to ask on the final is questions that whether something's in there or not. So in this one here, you have a set. The elements of this set are integrals. They're functions defined on 0, 1, and their integral must be finite. That's what that symbol means. It's less than infinity. That means it's a finite integral. So for example, is f of x equals 1 over x in there? Well, I just check by integrating. So for f of x to be in there, that integral's got to be finite. So I just check, is that integral finite? And it brings back so many good memories of Calc 2, improper integrals. There you go. You were sitting there in class, in Calc 2, saying, will I ever have to know this? Aren't you glad you had me for Calc 2? So here it is. It's an improper integral because I have an asymptote at x equals 0. So I set up an epsilon. I'm taking the limit as x goes to 0 from the right, from above. And I get plus infinity as my answer. Well, that's a problem, right? It can't be in that set because it's supposed to have finite integrals. So it's not in there. So it's not inside that set. So the only questions I'm going to ask you is this in there or is this not in there? So you just do an integration. What about orthogonality? How do you tell if something's orthogonal to something else? We take the dot product and check if it's 0. This is the definition of dot product on this space. So I just dot product these two functions with each other. and integrate. And I gave a straightforward one here, no trig functions, and you see that the integral turns out to be not 0. I didn't even finish it. All I had to know is not 0. I'm done. So because that dot product was not 0, those two things are not orthogonal to each other. So I gave you some sample problems, just checking if something's in there or not. And they basically are integration problems. Integrals are good for everybody. I was just thinking today, I was sitting in the dentist's office, that would be a great prank to, when you have to fill out those forms about all your health insurance, and just have a list of integrals. have the secretary finish these, and you have a minute to finish these, like speed drills from the little kid, and then have a bunch of people in there. Ever watch Just for Laughs? You need a good laugh, go to Just for Laughs. It's a Canadian show where they play these little pranks on people. So that'd be a great prank to play on people. Have people in there with graphing calculators, figuring out the problems when you walk in the dentist's office. I need a little humor. The DMV would be better. You know what? You get your driver's license after you fill out this form.